Hi, my name is Lisa Akselrod. I'm part of DevRel team in Aztec. How I ended up where I am now, I'm currently at ETHDAM in Amsterdam, crypto event dedicated to privacy. I'm here for two reasons. I work in crypto and I work in privacy. Before that, I worked for another crypto company that is not related to privacy, and it's obviously more fun to work for crypto company with privacy rather than for crypto company without privacy. How I ended up in crypto, I was fished by ZK, zero knowledge cryptography, because it's a lot of fun. And there are not too many things in the world that looks like true fun. I would maybe call three: surfing, great people, and awesome math. And the sad truth is that most math that isn't incorporated into the world as we know it, like in smartphones and computers, is not very fancy. Like, I don't know if someone knows how hash function looks. It's not very exciting. But in ZK, that we have currently in blockchain, we have something called elliptic curve cryptography. And we have something called Pairings. That is a part of elliptic curve cryptography. If you ask someone like, what is pairing, they will tell you, oh, just black box it. And this is what all people do. At some point, several people from PSC was like, okay, let's study pairings. And the first 16 months we spent in preparation just to be ready to study pairings. And I'm incredibly addicted to that stuff. It's like, just feels like a lot of fun. Even though for most people it doesn't feel like a lot of fun. If you ever showed up in, there is a project called ZK Hack, and they do study clubs. And they often run study club on Moon Math Manual. This is like the introductory book into ZK that combines a lot of like math and a bit of programming. And the study club starts, and there are like maybe 50 people. And then after like second session, they say, okay, this math, why do we need it? Like, why we can't just write code? And it assumes that like maybe 20 math lessons. And then by 10th lesson, you have like 3 people who are really interested in math. So the whole reason why I'm today in blockchain is because in blockchain there is ZK. And ZK is a lot of fun from the mathematical perspective. The repo of privacy project is orders of magnitude larger than the repo of like any other project, because you just need to build so many things that do not exist. Like in privacy in blockchain today, you need to build things that you do not know how to build, and no one in the world knows how to build. It sounds incredible. I think it sounds less incredible if you are VC who invested in this company, because like you can't really predict how long it will take you. Like Aztec is 8 years old, and it's not that it planned to be 8 years old by the launch of testnet. It just happened this way because, for example, we need to, like some basics. We want to have privacy. We need a definition what is privacy. After some like experimenting and like being familiar with products like Zcash or like something monofunctional, you're like, okay, we in fact want privacy to make it a tool for developers. We want people to be able to build different products with privacy. Then you need privacy to be flexible. Then you think, okay, what is privacy to be flexible? It means that you can make choice when you build an application, what you make private, what you make public, because monolithical privacy is very constrained. You think, okay, how we can do it? Like Aztec came up with using client-side proving. Client-side proving means that you want to process private data on like smartphone or laptop browser. And what it means that your RAM constraint is something like 1 gigabyte. And this is incredibly low for any proving system that is usually run on like 64 GPUs or something. So what Aztec has to do is redesign a number of crypto primitives and to optimize them for client-side proving. And then it's not like that. Okay, we build that. Then we do client-side proving. We need to design client-side execution. Then we look what is happening in the area we think about sequencing. We think about the fact that for this system to be long-lasting, we have to do it with decentralized sequencer. Even if maybe we would like to do it centralized, we just by design can't do it. So we start designing decentralized sequencer. And it's very tricky matter, like it deals a lot with mechanism design, where your kind of like experiments, what you can do without like launching the network, is very minimalistic, because we have testnet. Testnet is magic money. It does not reflect how the mechanism will work with real money. So it's also like very, very, very tricky. Then you also, like when you do mechanism design, you need to think about your counterparty. You need to try to come up with all types of mechanism hacks that the counterparty might come up with. And it's also like very tricky, but it's so much fun. It's like you are solving the problems that no one knows how to solve. I don't know what can be more fun than that. Today, like for people who are a bit less geeky than super edgy geeks, today is a great moment to start a ZK journey or privacy journey, because today you have Spectrum. If you want to be super heavy on mathematics and cryptography, you can go for it. You can take videos on YouTube, you can take papers, and just go for looking at what zero knowledge proven systems we have. We mostly have today two types. We have elliptic curve-based cryptography or hash-based cryptography, but also some like more experimental things like lattice-based cryptography. And you can just go for it. You just take a paper, you read the paper, you say, oh, I do not agree, this is wrong. You go on Twitter and argue with everyone, or do something more reasonable, maybe start a company, I don't know. But then as the next step, you might learn some mathematics, like some number theory about like fields, about groups, and then you can go for like more engineering side, but more low-level development, like using something like Circom language for people who are like kind of want to be a bit abstracted from cryptography in terms of having a programming language, but still want to be hands-on. Because when you're writing a circuit, when you're writing a ZK program, you pretty much, you want to prove that you have a program, it was executed on given inputs, and it was executed correctly. If you do it in low-level language, you have to write each particular constraint. It's like for people with some mindset who like low-level development, or like have feeling that they control what is happening. And then for people who want to work with ZK, but they want to be like abstracted from all the cryptography, they can go with something like Noir, the ZK language developed by Aztec, where it's high-level language, it's Rust-based language, and people pretty much do not need understanding of cryptography, and they still are writing ZK programs, and they can go more into like product world or like real world application world without thinking about technical aspects. And I think there are not too much, but quite few materials already on that today, and just a lot of people are learning these matters. So it's very fun to team up with other people who are learning and learning together. It's like hard to talk about it objectively, but I think that most developers, maybe 80% of developers in the world, prefer high-level languages, and they do not want to like deal with WASM-level languages, where like everything is very cryptic. So Noir is just quite simple and native in how you use it. Like you write a program, you do not write circuit, and then this program is executed and the proof is generated. So I think it's it's quite easy to pick up, at least like your first steps and like your beginning. And then the question is how you can use it. Noir is chain agnostic in general, meaning that you can write Noir. You can even write it outside of Web3, because what you do, you execute the program, you generate the proof, then someone verifies the proof. I can just send you the proof in WhatsApp, theoretically, and you will verify it. And if we assume that WhatsApp is a trusted channel, we are good. But in blockchain, we can go for, we have today Noir verifier on Starknet and on EVM chains. We can go for that. But in Noir, if we do it on EVM chain, we have to build something like monolithically private. We do not have the flexibility of states, of private and public state. We can do something that we put inputs on one side, then everything is private, then we get the output. And then if you want this flexibility, and very often in applications we want flexibility, for example, if we are building a crowdfunding platform and we want donations to be private, but we want the accountability of how they were spent, we want to have both private and public aspects. In this case, one can go with Noir on Aztec, and I think that here it becomes a bit tricky because in general, in Noir, there are some features that people did not get used to, such as you can't have dynamic size arrays. You need predefine all sizes. And people, for example, who came from Rust, they feel very uncomfortable with that in the beginning. Or we have a thing called unconstrained function, meaning that, in general, when Noir program is executed, it's ZK proven, the correct execution is ZK proven. But if you have some part of the program, some function, where you do not care about verifying the execution, you can kind of put it aside and only verify the result. It works for heavy computation when taking a root is heavy, checking that this number is the root of this number is easy. So you would like to take a root as unconstrained function and then just verify the result. So it just takes people, it's easy to pick up the basics, to start building your first app, to feel the syntaxes, to see how it works in your hands, to prove something, to verify it. And then it takes some time to learn the concepts, but those concepts give you completely new things that you can't do with any other language, with any other tool. And if people are fascinated by building something ZK, building something private, it's just, in terms of flexibility and being explicit, it's the coolest way to go. Thinking about how much do we need ZK for real, and not just because it's beautiful formulas. I think for blockchain privacy, ZK is the only way to go. If we're talking about trustless privacy, not like TEs, we do not take TEs here. They are trusted. If we want to go for trustless privacy, I would say ZK is the only way to go. If something is happening in the world and you want to ensure that it was done correctly and at the same time privately, you have only two options. You can either go there and check what was happening there, so you personally observe the correction. Is it still privacy? I'm not sure, but I think it's kind of how we can think about Web 2, where you kind of have a user and a server of the company, and the user kind of trusts the server of the company that it won't tell anyone. And the server usually doesn't tell anyone because it makes business on that. But it's this type of privacy that is not really privacy, but can be called also privacy. Or it should be cryptographically verifiable. And in this case, we pretty much have only ZK. And the very unique thing about ZK in general is that, for example, if you do symmetric encryption or some other encryption, you can have a backdoor. And we know that if you can have a backdoor, you will have a backdoor, because why not if you can? And in ZK, you can't have a backdoor by design. It's just this. It's physically impossible. And I think it's incredibly beautiful because it provides a type of objective truth, meaning that like the prover, like in ZK you have two parties, the prover who generates the proof that that the program was executed correctly on given inputs, and you have a verifier that verifies that the proof is valid. So by mathematical construction of ZK proof, the prover cannot generate that something is correct if it's not correct. It's impossible. And the same, the verifier can't say that the proof is valid if the proof is invalid, because it relies on mathematics. And it seems to be perfect fit for verifiability. Just especially for private verifiability, when you want to kind of attest that something has happened somewhere without knowing what. So the first thing, I think that for ZK, for privacy, ZK is the best fit, and we won't come up with anything else. We will just improve ZK in privacy and proceed with that. And looking at, we are just wrapping up today the Noir hack, and looking at a number of applications and the quality of applications, I became like one bit more confident that ZK is the fit for privacy. But also looking at ZK outside of blockchain, I think we have the world have today two parts. We have something physical, like we are here at physical event, and we have something digital, like we all chat on Telegram or maybe on Signal if we are a bit more advanced. And we have this blended physical plus digital world. And if in physical world we are somehow humanity managed to develop institutions to attest the truth. Like we have courts that if something feels wrong, we come to the court, we say to the judge, this is wrong, please investigate. And the judge tried to do his best or her best to somehow find the truth. In digital, it's way more obfuscated. It's we have tons of information everywhere. We have tons of LLMs processing this information and shaping the humans within the internet of how they should behave. And I think that there is huge fit there for also verifiability and for private verifiability. Especially if we think about something like proving AI models, proving LLMs, because LLM is huge. Several dozens of people worked on this model. This model tells you do this, gives you some recommendation. You have no idea if it's a good recommendation, bad recommendation. You can't recheck how the model was trained. Like comparing to Ethereum, for example, if we have the same model on Aztec, one validator executes the block, and then several hundred validators checks that it was executed correctly, and so they attest it. If it's computationally heavy, like LLM, training LLM is so hard that you will not attest it. You will never recompute how the LLM was trained. But you want to be able to question it, because the world as we know it today, I don't know how many LLMs shape my behavior in a day, maybe several dozens, maybe already several hundreds. And I'm afraid we can end up, it's a bit like doomer paradigm, but I'm afraid we can end up in the world where all the behavior of humans is shaped by LLMs. Humans are not aware and have no idea why LLMs are doing these actions. Because when you train the model, you have so many parameters, you have so many things to consider, you have such a high possibility of some flip-flop mistake or something without being aware of that. So in general, merging training models, or in general, any automation self-piloting vehicles or something that is happening on its own with verifiability seems to be a very good fit. Because we want to have machines accountable, we want to have AI accountable. We do not want it all to control us. it's very hard thing. It's not that like, oh, we can just take LLM, put ZK snark on top and it works. It requires like a lot of technical work. It requires a lot of like, let's call it educational and ideological work, because maybe not everyone will like the idea of LLM accountability, but it seems that it's worth working on, at least trying. And also, ZK-proven LLM is incredibly interesting technical task. If you are a mathematician or cryptographer or fancy engineer or curious engineer or fun engineer, I think today is incredible moment to start exploring ZK, because today it's not obvious. It's like, I don't know how many, but I think that maybe definitely less than 10,000 people in the world who understand like on a good level what ZK is. And maybe I would say, in my own like estimation, less than 100 people who are literally good ZK cryptographers, meaning that they can construct proven systems. We know that like in common sense, it can mean two things. It can mean that we are doing something that no one really needs, and that's why it's so small. Or it can mean that we are early and this is the right moment to start. And if we think about analogy with AI, like most large AI companies started in like 2003, 2004. In 2004, the penetration of like smartphone and internet was so low that most people like didn't believe that people will have computers, like that computer will be a consumer device. And thinking about like, okay, you want to run models on data, on like which data? Like where will you take from this data? The idea of large LLMs in like 2003 was like almost purely theoretical and didn't make sense for most people, if not all people. But there were people who like, this will be the thing. People who were able to like feel the world needs, feel the world sentiment, where it's all going with early internet times, with early computer times. And I can't promise you, but I personally feel like that very strongly, that this is the same model for ZK, for zero knowledge cryptography, because this is incredible verifiability tool, and the world is going deeper and deeper into more digital rather than physical. And whenever you have something happening digitally, you want to be able to verify it. Maybe not because you want to have objective truth, maybe because you just want to be able to navigate through the digital world in some like manageable way. So I think that everyone should work on what they feel good about. But if you have never touched ZK, just give it a try, like take several hours, watch some videos on YouTube, maybe read some paper, just give it a try and look at how it feels. And maybe you will find there's something for you that touches your heart, that talks to your feeling and understanding of the world. And then next year, when we will be in Amsterdam and IDDA, maybe you will be here too. This is a bit of a sad thing about ZK. It's not the most well-documented area. I would think if you are more into engineering, try Noir, try Circom. Noir if you prefer more high-level languages, Circom if you prefer more low-level languages. For Noir, go to Noir documents. This is the best place to start. For Circom, maybe try the book that is called Moon Math Manual. It also introduces some basics of mathematics. For mathematics, that's a good question. Maybe also try a bit of Moon Math Manual, even though for people who like mathematics, it's quite high level. Check the playlist of the project called ZK Hack. If you just open their playlist, it just lists the number of crypto primitives, and you will have no idea if you are coming from outside of the world. Pick anyone whose name you like the most, and just got some feeling of what is that. And then maybe you can't stop, or maybe you escape it forever. And maybe another thing, look at other ZK projects, try to read their code, try to understand how they're built. I think this is the good point to start. And another important thing is, if you feel that like you are trying to understand a paper or code or something, and you don't feel like you really understand, don't blame yourself. Blame the one who wrote this paper or wrote this code. It doesn't mean that they're really guilty, but it will make you feel better. Because ZK is incredibly beautiful, incredibly powerful, but it's also quite complex, and it takes time, and it takes effort. And if you like ZK, the next step, you need to bring your friends into it. And next year, we all will meet in Amsterdam.